Now the stunning discovery on Easter Island. A new ancient sculpture has just been found in a dry lake bed on that island.
For over 500 years, Easter Island's giant Moai statues have puzzled the world. Scientists measured them. They studied the quarry. They argued about how they were carved and moved. But no one had ever analyzed every piece of evidence together. Then, in 2026, researchers gathered every archaeological survey, GPS measurement, geological record, and structural study from Easter Island and handed them to AI. What happened next surprised everyone. The AI suggested the Moai were more than just statues. It found hidden patterns in their positions, astronomical alignments, and navigational directions. And if those patterns are real, they could completely change our understanding of why the Moai were built in the first place. So, what exactly did the AI discover? And why had those patterns remained hidden for centuries? Let's dive in. The island's mystery. Moai's giant stone figures have stood on Easter Island for centuries, watching the land in complete silence. Some rise more than 20 meters high. Some weigh more than 75 tons. Even today, they remain among the largest stone statues ever carved by human hands. Yet nobody knows exactly why their builders placed them across one small island in the middle of the Pacific. This island is called Easter Island, or Rapa Nui. It lies deep in the South Pacific, about 2,300 miles from the nearest continent. It is one of the most remote inhabited places on Earth. Looking at it today, it feels almost impossible that such enormous monuments could exist there. The island is small, its landscape rugged, and the ocean stretches for thousands of miles in every direction. Everything about this place feels isolated, and this isolation makes its story even more remarkable. Sometime between 700 and 1200 CE, the Rapa Nui people reached this distant island. They crossed vast stretches of open ocean without modern navigation. They brought no metal tools, and no written historical records from the builders have survived. Even so, they created something that still amazes archaeologists today. But their greatest achievement began only after they reached the island. Over the following centuries, the Rapa Nui people carved around 900 Moai from volcanic tuff. Most came from a single volcanic crater called Rongorongo. Workers shaped each statue directly into the rock before separating it from the quarry. The average Moai stands about 13 feet tall and weighs around 14 tons. The largest completed statue reached 33 feet. One unfinished giant still rests inside the quarry. If completed, it would have stood about 72 feet high and weighed nearly 270 tons. And then came the mystery which has puzzled archaeologists for generations. Building the statues was only part of the challenge. The builders still had to move these massive stones across rough ground to different parts of the island. For generations, archaeologists searched for the answer. Some proposed wooden sleds, others suggested rolling logs or ropes. Later experiments showed that carefully balanced statues might even walk upright, with coordinated pulling. Each idea explained part of the journey, yet none solved the entire mystery. However, one critical step had never been attempted. Researchers mapped the quarry, studied tool marks, examined stone surfaces, and recorded the landscape surrounding every monument. Each expedition expanded the evidence, yet every project examined only part of the island. No one had brought every survey, measurement, and record together into a single island-wide analysis. And for the first time in history, that was about to change. A powerful new tool entered the investigation. It could examine the entire island as one connected system rather than thousands of separate observations. And what it uncovered challenged decades of assumptions. The alignment patterns. By 2026, Easter Island had become one of the most thoroughly studied archaeological sites in the Pacific. Different research teams had examined different parts of the island over many years. Bringing all of that information together into a single analysis was simply beyond what any person or team could realistically do. Now, at this moment, scientists finally turned to AI to combine decades of scattered data. Researchers reportedly asked Grok to examine every archaeological survey, GPS coordinate, geological record, and structural measurement collected from Easter Island. Rather than focusing on a single site, the AI compared everything at once, searching for relationships that researchers might have missed while working on separate projects. But its first discovery did not come from the statues themselves. Instead, Grok began with the Ahu, the ceremonial stone platforms where the Moai stand. Archaeologists had measured these platforms for years, but they usually treated each one as an individual site. Grok mapped the GPS position of every Ahu and calculated the direction each platform faced, measuring the orientation down to fractions of a degree. Viewing every platform together allowed the AI to search for patterns across the island instead of inside isolated locations. Finally, one result quickly caught the researchers' attention. For generations, the accepted explanation said the Moai faced inland to watch over the villages. Grok did not dismiss this idea. Instead, its analysis suggested the statues might have served another purpose as well. After comparing every orientation with astronomical data, the AI reported a pattern that centuries of field archaeology had never examined as one complete dataset. What the AI found next turned everyone's attention to the sun. Based on the analysis, several Ahu aligned with important solar events, including the spring equinox, the winter solstice, and the zenith passages, when the sun passes directly overhead at Easter Island's latitude. The AI reported an average angular error of about 0.4 degrees among the Ahu it identified as astronomically aligned. Such precision made the reported pattern difficult to ignore and encouraged a closer review rather than an immediate conclusion. And the next step would decide whether the pattern deserved attention or not. To verify the AI's findings, researchers brought in archaeoastronomer Dr. Sarah Maroro for an independent review. She reportedly repeated the calculations 3 times before accepting the measurements. According to the source, she concluded the reported alignment pattern was extremely unlikely to have occurred by chance, though it remained a proposed interpretation. Even this pattern was not the most surprising part of Grok's analysis, because the statue's direction was only one piece of the puzzle. The way they were built would reveal another hidden pattern that researchers never expected: hidden navigation network. After examining the astronomical alignments, Grok looked beyond the statues themselves and followed the exact direction each Moai faced. Instead of ending the lines at the monuments, the AI extended every sight line across Easter Island and toward the surrounding Pacific Ocean. This single change uncovered a reported pattern that previous studies had never examined across the island as one connected system. Now, the results shifted the focus of the investigation. The extended sightlines did not stop at random places or nearby villages. They converged at specific points along the island's coastline before continuing toward carefully defined horizons across the Pacific. Rather than treating each statue as a separate monument, the AI suggested they might have formed one connected network spread across the landscape. And this possibility pointed toward one of humanity's greatest achievements. Long before maps, compasses, or modern instruments existed, Polynesian navigators sailed thousands of miles across the open ocean. They relied on the stars, the movement of ocean swells, changing winds, and knowledge carefully passed from one generation to the next. Their remarkable voyages connected islands separated by vast stretches of water. If the reported AI interpretation proved correct, the Moai may have preserved part of that navigational tradition in stone instead of spoken memory alone. But he reported analysis pointed towards something much larger than the statues alone. According to the source, Grok identified 11 convergence points around Easter Island's coastline. Each reportedly matched a bearing toward an important destination in the Polynesian world, including Hawaii, the Marquesas, the Society Islands, and the coast of New Zealand. Those reported connections encouraged researchers to explore whether the statues carried navigational meaning alongside their ceremonial purpose, rather than serving only as monuments. And the reported pattern attracted the attention of an expert in ancient navigation. The source identifies Dr. James Kalo as a specialist in Pacific navigation traditions. Dr. James Kalo described the reported findings as the most significant data on Polynesian wayfinding ever produced from a single site. He also suggested that, if the interpretation proved correct, the Rapa Nui may have encoded knowledge of their known world into the directions of the statues instead of preserving it only through oral tradition. Now, this possibility offers a completely different way to understand the Moai. They may have served not only as monuments, but also as lasting guides that helped preserve valuable knowledge for future generations. Even so, the reported AI analysis stopped short of proving this conclusion. It simply revealed another pattern worthy of careful investigation. Still, the investigation had one final layer left to uncover, and to reveal it, researchers had to leave the horizon behind and focus on the secrets held within the stone. Secrets inside stone. After tracing hidden patterns across the island and beyond the Pacific horizon, researchers reportedly asked AI whether the stone itself might hold another clue. This time, Grok stopped studying where the Moai stood and began examining how they had been built. And its attention quickly turned to one unusual feature. Many Moai wear large red stone cylinders known as pukao. For years, researchers described them as ceremonial hats placed on top of the statues. They seem simple at first glance, yet the reported AI analysis suggested they deserved much closer attention because creating and placing them required considerable effort. Among all those findings, one detail immediately stood out. The builders did not carve the pukao from the same stone as the Moai. Nearly every Moai came from Rongorongo, a volcanic crater that served as the island's main quarry. There, the Rapa Nui carved the statues directly into volcanic tuff before separating them from the rock. The pukao, however, came from Punapau, another quarry elsewhere on the island. Workers carved them from red volcanic scoria, a completely different volcanic material, and this single difference changed the entire investigation. Transporting the pukao meant the builders first moved the enormous Moai from Rongorongo and later carried the heavy red stones from Punapau before placing them on top of the finished monuments. According to the reported AI analysis, that extra effort suggested the pukao may have served a purpose beyond simple decoration. Soon, the investigation uncovered another hidden detail. Grok examined the monuments using center of gravity modeling. The reported analysis suggested that adding a pukao changed how each statue balanced. That observation encouraged the AI to explore another possibility instead of stopping with structural measurements. So now the investigation turned from stone to sound. Grok modeled the acoustic resonance of statues with and without pukao. The reported results suggested measurable differences between the two groups. The AI also proposed that these resonance patterns may have matched different navigational categories identified during its earlier analysis. Even so, the source presents this idea as a hypothesis rather than an established archaeological conclusion. But one neglected feature still remained: the ancient roads themselves. Researchers have long viewed the roads leading away from Rongorongo as routes used to transport the Moai across the island. According to the reported AI analysis, Grok also examined their width, layout, and surrounding stone. The source claims the roads possessed acoustic properties that may have supported large human processions. This interpretation remains debated because archaeologists have not reached a consensus. But you know what? The biggest surprise was not what the monuments may have encoded. It was what the timeline of their construction was about to reveal. Knowledge slowly faded. Now Grok shifted its focus from where the Moai stood to when people built them. Instead of studying the monuments as a single group, it compared radiocarbon dates, construction phases, tool marks, structural precision, and alignment measurements across different periods of monument building. Researchers expected centuries of experience to produce greater accuracy. Based on the source, the reported results suggested the opposite. Surprisingly, one pattern immediately separated the earliest monuments from the rest. The first Moai, carved at Rongorongo, displayed the highest level of precision. They showed the most accurate astronomical alignments, the most deliberate orientation, and the strongest engineering consistency identified during the reported analysis. As new generations continued carving statues across the island, that precision gradually declined instead of becoming more refined. Rather than revealing steady improvement, the timeline appeared to show that something important slowly changed over time. However, the AI found that the change could actually be measured. The earliest confirmed alignments showed an average error below 0.3 degrees. During the final construction phase before monument building ended, the reported error had increased to about 2.8 degrees. The AI interpreted this growing difference as more than ordinary variation. Instead, it suggested that later builders may have preserved the traditions while gradually losing the detailed knowledge that originally guided the monument's exact placement and orientation. Now, this interpretation shifted the story from engineering to human history. The earliest builders may have fully understood why each monument belonged in a precise location. Later generations, however, may have continued following the same traditions without preserving every reason behind them. The reported analysis suggested this possibility could also explain why one enormous Moai still remains unfinished at Rongorongo. The giant statue still rests partly carved into the quarry wall, leaving behind a silent reminder that the work ended before the monument ever reached its destination, and one ancient artifact still seemed capable of telling the story. Attention turned toward the Rongorongo tablets, one of the world's few independent writing systems and one that scholars still cannot decipher. Researchers gave Grok documented Rongorongo symbols alongside the astronomical, navigational, engineering, and structural information it had already examined. The reported comparison identified several symbol clusters that appeared with statistically significant frequency near particular astronomical locations. The reported results encouraged researchers to examine the symbols in a completely different way. Those recurring symbol groups may have recorded astronomical knowledge instead of stories or everyday language. The analysis also suggested that other clusters might relate to navigational bearings and distance notation. Even so, the source emphasizes that these ideas remain preliminary hypotheses requiring further academic validation rather than accepted archaeological conclusions. Yet after connecting every clue together, the mystery only became deeper. Because if the patterns were real, who first developed this remarkable knowledge? How did they acquire it? And why did later generations seem to lose it? Even Grok could trace the patterns. It could not explain their origin, and those were only some of the questions that still had no answers. Questions without answers. The AI had connected astronomy, navigation, engineering, acoustics, roads, writing, and chronology into one possible system. Yet connecting patterns did not automatically prove that the interpretation behind them was correct. The evidence still required careful testing, independent review, and future archaeological work before anyone could treat those ideas as established history. In fact, one truth remained impossible to ignore. The island itself no longer looked like a random place filled with isolated monuments. The geometry of Easter Island, the positions of the Moai, the reported astronomical alignments, the navigational sightlines, the resonant pukao, the ancient roads, the undeciphered Rongorongo tablets, and the gradual decline in construction precision all appeared to fit within one larger framework. Whether that framework reflected the intentions of the original builders remained the central question. The reported patterns opened three very different possibilities. The first possibility is that the Rapa Nui developed this remarkable system on their own after arriving on Easter Island between 700 and 1200 CE. If that interpretation proves correct, one of the world's most isolated civilizations created an advanced system of astronomical, navigational, and engineering knowledge unlike anything yet documented elsewhere in Polynesia. Then, the second possibility, and it's a completely different story. The Rapa Nui may have inherited this knowledge from earlier Polynesian traditions that later disappeared across the Pacific. According to the reported AI interpretation, the Moai could preserve fragments of that forgotten knowledge long after the people who fully understood it had vanished. If true, the statues would represent far more than monuments. They would stand as a lasting record of an ancient understanding of the sky, the ocean, and long-distance navigation. Finally, the third possibility shifts the focus to the island itself. Easter Island's unique location may have offered natural observations unavailable elsewhere in the Polynesian world. The Rapa Nui may have recognized those conditions, studied them over many generations, and carefully encoded what they learned into the monuments, the roads, and the Rongorongo symbols. Even this interpretation remains a hypothesis that requires much more archaeological evidence before researchers can accept it as established history. But one principle separates discovery from proof. Artificial intelligence recognizes patterns at a scale that people cannot easily manage. Archaeology explains those patterns through excavation, evidence, and careful testing. The reported Grok analysis generated new hypotheses, not final answers. Every important claim still depends on independent verification and future research before it can become accepted history. However, looking beyond the evidence reveals something even more meaningful. Ancient civilizations may have preserved knowledge in ways modern researchers are only beginning to recognize. Perhaps the greatest achievement of this investigation was not solving Easter Island's mystery. It was reminding us that some of humanity's oldest monuments may still hold stories waiting for the right questions to uncover them. The greatest mysteries do not always disappear with time. Sometimes they simply wait for a new way of being understood. AI may have revealed remarkable patterns, but it has not solved Easter Island's mystery. Instead, it challenged us to look again with fresh eyes. So it's your turn to answer. Which explanation do you find most convincing? And what do you think the Rapa Nui were trying to preserve for future generations? Let us know your thoughts in the comments below. If you enjoyed this video, don't forget to give it a thumbs up. And if you want more incredible mysteries, discoveries, and true stories like this, be sure to subscribe to the channel. Thanks for watching, and we'll see you in the next video.